So there was a cool little study that was recently published in the journal Nature, which suggested that birds may have gained their colorful eggs from their dinosaur ancestors. It's an interesting story of evolutionary adaptation and the continual inheritance of those adaptive traits across millions of years. Jasmina Wyman is a paleontologist at Yale University, and she was one of the researchers who worked on the paper. She said, quote, "There's a huge diversity in egg color and pattern. For a long time, people have assumed that egg color is a trait that's unique to our modern birds," unquote. This assumption came from the fact that crocodiles, which are the closest living relatives to birds, quote, "have completely uncolored, unpigmented eggs," unquote. The researchers then wanted to see if they could find color in older eggs, in the eggs of animals that lived long ago, before birds or crocodiles ever appeared. They based their research on an older study that found, quote, "the presence of both red-brown protoporphyrin 9 and blue-green biliverdin, the pigments responsible for all the variation in avian egg color, in fossilized eggshell of a non-avian dinosaur," unquote. So basically, they found these pigments that are used in bird eggs to give the bird eggs color. They found these pigments in dinosaur eggs. Then, the researchers fired up their high-resolution microspectroscope and used it on eggshells from all of the major clades of dinosaurs. And they found, quote, that egg color pigments were preserved in all Humaniraptorans, unquote. Thus, they reasoned that, quote, egg color had a single evolutionary origin in non-avian theropod dinosaurs, unquote. These pigments were only found in theropod eggs, and theropods are the ancestors of birds. The pigments weren't found in sauropod or ornithischian eggs. Furthermore, the pigmentation patterns in these fossilized theropod eggs were described as, quote, spotted and speckled, and color pattern diversity in these eggs approaches that in extant birds, unquote. Mrs. Wyman described the evolutionary context in which dinosaurs would have evolved these colored eggs. While talking specifically about the oviraptors, relatives of the famous velociraptors, she said, quote, "This dinosaur is particularly interesting because oviraptors are the first dinosaurs that built open nests. Once you start to build an open nest, your eggs are exposed to the environment," unquote. This is a really important detail to take into consideration, because if you have white, uncolored eggs, they would be highly visible in an open nest that's built in dark soil, and so it would be really easy for some nearby egg-stealing predator to see the egg, identify it as an egg, and then steal it. So the eggs that had these colorations and speckling were slightly more camouflaged, and presumably slightly less easy for these egg-stealing predators to identify and steal to eat. Thus, the eggs that had these shells were more likely to survive and hatch, grow into adults who would then reproduce on their own to make more of these colored eggs, and so on and so forth. The fact that the dinosaur eggs had this speckled and spotted patterning is also a really exciting detail. Mark Haber is an ornithologist from the University of Illinois, Urbana-Champaign, and he said, quote, "We not only know now that dinosaur eggs were colorful, but they were speckled, which is a whole other aspect of diversity. Dinosaur eggs could have been camouflaged. They could have been individually recognized. They could have been mimemic. So there are all the functions that are associated with spotting patterns on eggs that we did not even consider for dinosaur eggs," unquote. Essentially, he's saying that all of these morphological and physiological features of the spotting and speckling patterns on the eggs, these functions that we know exist in birds, presumably also existed in their dinosaur ancestors. The ultimate conclusion of their paper is that modern birds, quote, "were not the first amniotes to produce colored eggs. As with many other characteristics, this is an attribute that evolved deep within the dinosaur tree, and long before the spectacular radiation of modern birds," unquote. This is super interesting research, and it's exciting to learn more about the evolutionary history linking the ancient, extinct dinosaurs with their distant descendants in the modern birds.